For the quadratic function right here, what are the coordinates of the vertex? So remember, it's at h comma k. And remember, it's x minus h. So this would be x minus -1. And then -5 for k. The parabola is positive, so it's going to be pointing up. So the vertex is going to be a minimum. Graph the parabola below. So -1, 1, 2, 3, 4, 5 goes right there. First, I'll find the y-intercept by plugging in 0 for x. So I get y equals 2 times 0 plus 1 squared minus 5, which is 2 times 1 squared minus 5, which is, we have to do 1 squared first. 2 times 1 is 2. 2 minus 5 is -3. So it's at 1, 2, 3, -3. Then we can put the symmetry point on the other side of the line of symmetry, right there. The x-intercepts, we plug in 0 for y. 2 times x plus 1 squared minus 5. So we add 5 to both sides. 5 equals 2 times x plus 1 squared, divide by 2. 2.5 equals x plus 1 squared. To undo the square, we have to take the square root. The square root of 2.5 is plus or minus 1.6. So we get plus or minus 1.6 equals x plus 1. So that breaks out into positive 1.6 equals x plus 1, or negative 1.6 equals x plus 1. We subtract 1 from each side. X equals 0.6, or x equals -2.6. So 0.6 would be right about there. -2.6 is -1, 2, and then halfway. Here's our parabola. Aura currently pays $800 each month to rent her apartment. Her rent is increasing by $50 every year. Meanwhile, her monthly take-home pay is $1,500, and she predicts that her pay will increase by only $15 each year. Assuming that her rent and take-home pay will continue to grow linearly, how many years will her rent equal, after how many years will her rent equal her take-home pay? So, let's see. We want to let total rent equals $50 times t. I'll let t equal years. So her rent is going up by $50 every year, and it's already $800, so plus 800. And then her total pay grows by $15 each year, so 15 every year plus 1,500 is what she makes right now. So we want to know, when is the rent going to equal the pay? So we set them equal to each other. We want to know, when does 50t plus 800 equal 15t plus 1,500? And we just solve this. So we get 35t plus 800 equals 1,500 minus 800. T equals 35t. 1,500 minus 800 is 700. Divided by 35. 700 divided by 35 equals 20. So in 20 months, her take-home pay, how much money she makes every month, will equal her rent. That would be very bad, because then you'd have no money to pay for anything else. Complete the square to convert y equals x squared plus 2x plus 3 into vertex form. So right now, we've got x squared plus 2x's plus 3. But if we want to convert this to vertex form, we only need 1. So in order to get our 1 tile here, we have to subtract 1 from both sides. So we get y minus 1 equals x squared plus 2x. Sorry, we have to subtract 2. Y minus 2 equals x squared plus 2x plus 1. So we had 3 tiles. We subtract 2 so that we're left with 1 tile, because that's how many we need to complete our square. And then this equals x plus 1 times x plus 1. So you can rewrite it. Y minus 2 equals x plus 1 squared. Then we just add the 2 back to the other side, and we get y equals x plus 1 squared plus 2. And our equation is in vertex form. A farmer wonders whether his crops grow better in sun or shade. He measures the amount of fruit gathered from a sample of 50 trees growing in full sun and 50 trees growing in full shade. The 5 number summaries, which includes the minimum, the first quartile, the median, the third quartile, and the maximum. So this is the minimum, this is Q1, this is the median, Q3, maximum, are below. So first we want to create a box plot. So I noticed that my data needs to go all the way up to from 10 to 130. So let's see, if I start here at 0, 10, 20, 30, I could probably skip by 5s. So 5, 10, 15, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So we're going to make 2 box plots, one for sunny trees and one for shady trees. So the sunny minimum is 10.8, so that's just pretty close to 10. The Q1 is 13.3. Let's see, so halfway is 15. So 13 is just right there. The median is 22. And the third quartile is 58, which is really close to 60. So here's our box. And then we have a short little whisker there. Then the maximum is 100. For shady trees, the minimum is 10.8 or 10.9, which is about the same. Q1 is 18, which is closer to 20. The median is 29, which is pretty close to 30. Q3 is 61. So we can draw the box. And then the maximum is 127, which is over here. So let's remember that this is the amount of fruit gathered from the trees. It's how many bushels. So this is number of bushels. And the farmer probably wants to gather as many bushels as he can. So should the farmer plant in the sun or the shade? Support your answer with mathematical evidence. So I noticed that for the shade, everything is higher. The minimum is slightly bigger. The first quartile is bigger. The median is bigger. The third quartile is bigger, and the maximum is bigger. So it looks like the shady tree gives him more bushels. Or the shady trees give him more bushels. So the shady trees produce more bushels. All of the data minimum, Q1, median, Q3, maximum, all of that data was higher for the shady trees. The farmer should plant in the shade. The farmer wants to summarize the amount of fruit from each type of orchard with a mean and a standard deviation. Is that appropriate? Explain. So I would say that this is not appropriate to use mean and standard deviation because these box plots are not symmetric. If the box plot were symmetric, meaning if the median was in the middle, the whiskers were about the same size, and the box plot looked the same on both sides, then it would be appropriate to use the mean. But the mean is not, so the mean and standard deviation are not appropriate because the data is not symmetric. So the median and IQR would be a better summary of the data.